How can simple robots with limited memory complete complex assembly operations? We are given a two-dimensional, connected set of grid tiles that form a polyomino. Our robots operate as finite automata. They can move around and sense, place, or remove tiles. However, the robots move by walking on the structure, and so must keep the tile arrangement connected. We show how two finite-state robots are sufficient to construct the bounding box for any given polyomino. This video shows our 2D simulator that uses a state machine to build a rectangular boundary. The implemented state machine has 34 states, which includes some optimizations for shifting long stretches of tiles. When the robots are in close proximity, they behave synchronously. In each state, the robots first sense one unit in the directions left, up, right, and down. Our 3D simulator is based on NASA's Billi robot. At bottom right is a Billi executing a state machine to move on an expanding row of voxels. By sensing the existence of a neighboring voxel, the Billi can walk to the end without falling off. The top left shows our 3D simulator using similar sensing to detect neighboring voxels. The underlying motivation is the construction and modification of space facilities of enormous dimensions, where the combination of new materials with extremely simple robots promises structures of previously unthinkable size and flexibility. This is also closely related to the newly emerging field of programmable matter. We end with an example where the robots start inside the polyomino. These robots must detect that they are inside the polyomino, deconstruct the bounding box they were constructing, move outside the polyomino, and then construct the bounding box.